There are several different kind of correlations. We're only going to go into the Pearsons and the Spearmans. First of all, if your data is continuous, in other words, that you can have decimals and fractions and there's a real zero, that's a continuous variable. Regular counting number is a continuous. That's a Pearson's. If your data is ordinal, such as like a Likert scale, then you use a Spearman's. Okay, a Spearman's uses ordinal, Pearson uses continuous. Part 2, you got to know that these are cause and effect variables. In other words, when one variable changes value, does it affect the value of the other variable? So also called explanatory and response. They go by many names, but you got to know it's basically a cause and effect, even though we don't say cause and effect. Moving on. So if you had two variables and they're both continuous, that means you're talking about a Pearson's correlation. So an example, does exercise have anything to do with weight loss, right? Cause and effect. Another example, does job satisfaction have anything to do with work productivity? Cause and effect. Last one, does depression have anything to do with marriage satisfaction? Cause and effect. In other words, when the value of one of these changes, does the other one change as well? Moving right along. I'm going to take an example, exercise and weight loss, my favorite. So what you're going to do is you're going to collect data. So these are the subject, each one, subject 1. Remember, each subject has to have two values, one for each variable. So you have your data set comes in pairs. Okay, so this person exercised 216 minutes, lost this much weight. I'm going to fill in the rest. So you have two variables, both continuous. You're going to see if the relationship between exercise and weight loss is strong, medium, or large, or, small, medium, or large, or whether it exists at all. So again, you have every data piece is used has to have two sets. If one is missing, you should probably not use that subject in your study. All right, let's get going. There's the actual by hand formula. This little s sub x is the standard deviation of the first variable. S sub y, standard deviation is second variable. The x sub I is each individual piece of data. Each individual piece of data. That's what that means. Okay, we're not going to do this by hand, so don't freak out on me. Y sub y is the same thing. It's each individual y. X bar is the x mean, and y bar is the y mean. And there's R. That is our symbol for the correlation. What you should know in Excel, let me do it for you in Excel. Don't blink. This goes fast. Pick a cell, any cell. Go to the function bar. And make sure you're in statistical. And go down to correlation. Click OK. Array means column or row. So make sure you're blinking in here. You're going to highlight the first one. Click your cursor in the second one. Highlight the second one. Click OK. You're going to get your correlation, right? There's your correlation. That's how you do it in Excel. There's another way to do it. You can go through the data, and you can go to data analysis over here, and you can do it that way. But again, this is a quickie tutorial. You want to learn more, you go back and watch the regular videos in our Moodle. So there is our correlation and Excel. One important thing, Excel does not give you significance. It will not tell you if this is a significant correlation or not, even though it's incredibly strong. It's almost perfect. Our sample size is small, so significance does include sample size. So to find if it's significant or not, we're going to switch to SPSS. So I ran it through SPSS, and it was significant. So we do have definitely a strong, significant correlation between exercise and weight loss. Now, you also got to know this, that all correlations must be less than or equal to -1 or greater than or equal to -1. In other words, it has to be between -1 and +1 inclusive. It could be -1, it could be +1. But if you have something like 1.67, that can never be a correlation. All right, and to find the effect size of a correlation, all you do is you square the R. Say that again. The effect size of a correlation is you simply multiply R by itself. And what is effect size? Effect size is the percent of the variance in the relation that can be explained. That is your effect size. Very important concept. And here's your effect size table. You'll notice different tests have different effect sizes. And ours is either R or R squared. You could take whichever one you want. And ours was 0.9, so our effect size is crazy large. So a scatter plot. We're going to make a scatter plot in SPSS. I'm sorry, Excel. So what you do first is you highlight the data. You go to Insert, and that's your scatter plot. You can go to Recommended Charts if you want. Doesn't matter. It'll tell you all the time. It's usually right. That's the one I want. Click OK down here. And there's your scatter plot. So let me put that on our thingy. There's our scatter plot. Next thing you're going to put in is a trend line. So to put a trend line in, all you do is you hover around any point until you get that little series 1 point blah, blah, blah. You right click. You're going to add a trend line. Let me drag it over here where you can see it. You get this bad boy box. You're going to scroll down to the bottom. You're going to put, let me make it a little bit smaller so you can see the whole thing up here. Get up there, you. You're going to put the equation on the box. You're going to put the display R squared on the box. And it automatically puts the trend line in there. So remember, hover, right click. You want a linear trend line. You want the prediction equation on the chart and the R squared on the chart. So that gives us that. There's the trend line. There is the equation of that trend line, and this is called the regression equation or the prediction equation, and that's about it. That's everything I expect you to know about a correlation. MGZ out.